The change in enthalpy, or delta H, can be additive in multiple step reactions. So for example, down here, I can go directly from step 1 to step 3, or I can go from step 1 to 2 and then from 2 to 3. Going from step 1 to step 3, I can find my delta H. If I go from 1 to 2 and then 2 to 3, when I add them up, my 2's are going to cancel and I'll have 1 to 3. So my delta H's should add up to equal the first one. So let's say the first one is a 10 and this one is a 4 and this one is a 6. They would add up to be the same thing. So this is Hess's law, where you can take reactions and add them up and manipulate them to find a target reaction. Some key concepts. When you need to reverse a reaction to add it up properly, you're going to change the sign on the delta H. And if you multiply the equation through by a number, you also multiply the delta H by the same number. Enthalpy is a state function. You get the same value no matter how you got there. So getting there in one step or getting there in 2 steps, your delta H or your enthalpy will be the same. So let's look at this problem. Here's my target equation. So that's what I want to find my delta H for. And I'm giving these 2 equations. So you're going to ask yourself 2 questions. Is it on the correct side? And the second question is, do you have the right amount? So let's start off with my first equation. So in my first equation, I have an E go to an F, and looking at my target equation, I see there's a 2 in front of the E. So I'm going to have it match the target equation because that's our goal. So I'm going to put a 2 in front of everything. Everything gets multiplied by 2. And then let's look at the next one. So I have my next equation, I have G going to 2F, and I can see my G here and my G here, it's on the wrong side. So I need to rewrite that. So I'm going to reverse it. And that also reverses the sign on my delta H. So I rewrote that one, so I'm going to cross it out so I don't accidentally rewrite it. So let's go ahead and add these 2 equations and hope that it equals the target equation. If it equals the target equation, then I have the right delta H. So when I add this up, I can bring everything down. Let me cancel out what's on both sides so that 2F goes away. And so I end up with my target equation. So this is the answer. Delta H is a negative 30. So we just add them up. So this is a lot simpler than doing the equilibrium K's, where they always have to be multiplied and squared and divided. This one is just very, very simple and straightforward. If you multiply an equation by 2, then you multiply the delta H by 2. So let's do this problem. This one's a little bit more complicated. We have our target equation down here. So I'm going to go through each equation that they give me and try and manipulate it so that when I add it up, it will equal the target equation. I see that the first one has a C2H2. That matches up. And it looks like it's on the correct side, and it looks like I have the correct amount. So I'm just going to leave that alone. So let's go to the second problem there. And I see there's a 2C. And none of the other problems have carbon in it. But I see that it's not on the correct side, and I don't have the correct amount. So I'm going to reverse it. And this will reverse the sign. And then I need to multiply through by 2. So everything gets multiplied through by 2, even my delta H. All right, and I rewrote that, so I'm going to cross it out so I don't get confused and add it when I shouldn't. And then let's look at our last one. So our last one, I see that I haven't talked about hydrogen yet. I haven't looked at hydrogen yet. So I see that it's not on the correct side, so I'm going to reverse it. And this reverses the sign. And it's on the correct side now. Do I have the correct amount? It looks like I do, so just a 1. So let me cross that out. Let's go ahead and add these. Let's see if I can cancel anything out before I bring it down. I see that there's a 2 CO2 on each side, so I can cancel that out. Oh, there's a water. And there's a whole bunch of oxygens. So I have 5 halves oxygen, so that is 2.5. So that is both those oxygens. So let's bring everything down and hope it's our target equation. And that's all that's left. Everything else canceled out. So that means I can add all of these, and I should get my answer. My final answer is a negative 227, so an exothermic reaction. We can get there in 1 step or in 3 steps, but we should have the same enthalpy. And this is called Hess's law.